Hi, today we are going to review static electricity. If we have a +4 charge sphere and a -2 sphere and we touch them together, I want to know what the charge on each one is. Now remember, conservation of charge states we can't create or destroy charge, we can only transfer it. So we're going to take our +4 and our -2 and add them together. Add them together, and we are going to get a +2 divided by the number of items we have, and we are going to get each one is going to be +1. Next thing we're going to look at is an electroscope. If we have an electroscope, we have it negatively charged next to it, a negatively charged rod. There is a positive charge in there. That's just to show you that there are still protons residing in it. There's just more negatives than positives. So what would the not be? If we have negatives, what is attracted to it? Positives are attracting it. Now what is repelling the negatives of the rod? The other negatives, and they're going to go down here, and these leaves are going to repel each other. Our next slide is going to be charge and whether or not we can have an acceptable charge. Now we remember that in one elementary charge there's 1.6 times 10 to the negative 19th coulombs. So one of these isn't going to work. We need to have an integer value for electrons. You can't have half an electron. So we're just going to figure out which ones will work. We have, in this one we'll have 1 electron, this one we would have 2 elementary charges, this one would not work. So we know that that's the right answer for this problem because it doesn't work. My next problem that we're going to try is 2 positive spheres. Now 2 positives are going to repel each other, and I want you to draw the field lines. Now remember our mnemonic that says positive people give and negative people take. So if we have positive charges, they are going to be givers. So they're repelling each other, but they're positive, so make sure the arrows are headed out and they curve. Now make sure your field lines do not cross. And that one would look like that. My next problem I'm going to try is if I have 2 charged particles. I have a -2 and a -8 elementary charges. I want to know the force between them. Well, my equation is going to be Fe equals K Q1 Q2 all over R squared. My first thing I have to do is change my elementary charges to coulombs. So to do that, I'm going to multiply them both by 1.6 times 10 to the negative 19th. So I have this first one is going to be negative 3.2 times 10 to the negative 19th. And my other one, when I multiply it by 1.6 times 10 to the negative 19th, is going to be negative 1.28 times 10 to the negative 18th coulombs. So now we're just going to plug everything into my equation. Fe equals, now K is on the front page of your reference table, 8.99 times 10 to the 9th Newton meters squared over Coulomb squared times the negative 3.2 times 10 to the negative 19th times negative 1.28 times 10 to the negative 19th all over the 0.5 meters. Now don't forget to square it. And you find out that your force between them is 1.47 times 10 to the negative 26 newtons. Now, I'm supposed to draw the force vectors on that. So which way are they going to go? Well, they're both repelling each other, so they're going to go that way and that way. And then I have this cool video of lightning to show you. Hi, all right, we're going to finish up this static electricity review. And we have an electron placed in a field of 50 newtons per coulomb. What's the force on the electron? So we know the field is 50 newtons per coulomb. We're looking for force. And we know that the charge of an electron is 1.6 times 10 to the negative 19th coulombs. So we multiply across and we find out the force is going to be 8 times 10 to the minus 18 newtons. So my next problem is I'm trying to find the energy in electron volts to move one electron 10 volts. So we have our 10 volts, and we have one elementary charge. So we have, multiplying across, our energy is 10 electron volts. Now, if we want to convert that to joules, we know on the front page of our reference table, they say 1 EV is equal to 1.6 times 10 to the negative 19 joules. So we are just going to multiply our EVs, EV by the 1.6 times 10 to the negative 19 joules, and we will get 1.6 times 10 to the negative 18 joules as our answer. Our next problem, we have a proton and it's directed up towards plate A. So if we have a proton, we know that that's a positive charge, and if it's directed up towards plate A, it must be attracted to plate A, and therefore that must be a negative charge. Plate B would then be a positive charge. And our three field lines, we know they go from positive to negative. Positive people give, negative people take. So straight lines going up. All right, our next problem is going to be a circuit. We're going to draw a circuit with a power supply of 10 volts and one 25 ohm resistor. I'm going to put in a voltmeter and an ammeter. So power supply. Then we're going to have our resistor, put our ammeter in. Remember, ammeters have to be in the circuit to read. And then we'll have a voltmeter that can go around our power supply. Then we have to find the current in the circuit. So we'll use V equals IR, 10 volts, and 25 ohm resistor. I is 0.4 amps. My next part is to figure out the power used by the resistor. So we're going to use our equation, P equals IV. You could also use V squared over R if you wanted to. I have 0.4 amps times 10 volts would get me 4 watts. Now I also have to figure out the energy. If I leave it out for 1 minute, my energy equation is going to be W equals PT. P was 4 watts. Time for 1 minute, don't forget to turn it into seconds, 60 seconds. So I have 240 joules. The last problem I'm going to do today is my favorite. If we have 8 coulombs passing through a circuit in 2 seconds, what's the current? Don't forget my favorite equation, I equals Q over T. I am a cutie. So we have I equals 8 coulombs divided by 2 seconds. It's going to be 4 amps. And we are all set. Have a good day.